The following experiment will demonstrate that what we perceive as curvature of the Earth due to its spherical surface may actually be atmospheric phenomena occurring over a horizontal surface. This experiment can be conducted on various level surfaces, both indoor and outdoor, basketball courts, tennis courts, ice rinks, and so on. It can even be conducted over small ponds and bodies of water. These observations show that a spherical surface is not necessary in order to witness objects disappearing from view bottom up. Theoretical curvature cannot be pointed to as the cause for the apparent sinking in the experiments presented here, as these observations all take place within 600 feet, which is not enough distance for any of the said curvature to be present at all. We will also demonstrate that, from a distance, the bottom floors or layers of buildings and structures also disappear because of atmosphere over a horizontal surface, not disappearing behind a curved one. We will be using a scale of 1 inch equal to 5 feet. Our viewer height will be 1.5 inches, so 7.5 feet to scale. These observations are being made over small ponds, which produce small waves, accurately simulating the waves seen when boats sail on the ocean in large water. A wave of about an inch or so on our experimental ponds would represent an ocean wave of approximately 5 feet. This first observation was made on July 24th, and the temperature was around 82 degrees at the start of the experiment. The blue toy boat represents a boat that's approximately 30 feet long by 8 feet tall. The yellow and orange boat represents a vessel that would be 25 feet long and 15 feet tall. During the hottest parts of the day, the boats disappear hull first while moving away from the viewer and camera, but they do so above the apparent horizon. This is to be expected due to the variation in temperature of the air and the temperature of the water. As the evening presses on, the temperature in the air cools down, and the boats begin to disappear hull first at or below the apparent horizon. Next, we'll see objects that are set up across the pond to represent a distant city skyline. Like the larger buildings and structures whose bottom layers are no longer visible, seeming to be sunken below the ocean horizon, these objects will also be missing their bottom layers. This rough miniature skyline is placed approximately 550 feet away from the viewer or camera, which is 6 1/4 miles away to scale. With the viewer height of 1.5 inches or 7.5 feet, we can expect to be missing just over an inch from the bottom of the skyline objects, representative of about 5.5 feet. Notice how when we view the skyline from a higher vantage point, all of the objects are in view. But when we go down to the water surface, most of the objects are no longer visible. Reminder, we are not merely seeing these objects from a higher view because we are raising above a curve, and they are not disappearing behind a curve when we drop our view. This pond is too small for that to be the case. Notice the dramatic disappearance at the bottom of the objects after just a slight change in viewer height. This observation takes place in 27-degree temperatures and will include another toy boat and representative city skyline, this time with the boat sailing to the skyline objects. On this day, the cold air above the warmer water causes miraging and lots of atmospheric distortion as the boat sails off. This last observation takes place on a clear day at 38 degrees. Because there isn't extreme variation in temperatures between the air and water, we see the boat appear to sink below the horizon. The boat is completely out of sight while it sails by the skyline objects, with only its water trail visible. Rising up allows us to see both the bottom of the skyline and the boat sailing in front of it. To summarize, what these observations show is that what we perceive and call curvature of the Earth isn't actually physical curving of the surface, but rather we are witnessing the bending or curving of light through dense layers of atmosphere over a horizontal surface such as the Earth's oceans and lakes. We expect light to travel in straight lines, but we know that light travels slower in denser mediums, creating the illusion of curvature.